So this is your homework problem today for a Boolean function f of a b, minterms 0, 2. We have to prove that f of a b max terms 1, 3 and complement of this minterm 1, 3 and max term 0, 2. They are all the same, right? So that is what we have to do. So we'll start with the first term we have. So in order to approach the solution, right, so we can take this term first, right? We have to find what is the actual value of this, right? And we'll find this and this individually, right? And see that they are all the same. So we can draw a solution, right? So what is your given data? Given data is f of a dot b, which is equal to minterms 0, 2, right? So we have a 0 and we have a 2, right? So we can convert this 0, 2 as 2 bits 0, 0 and 1, 0, right? So for 0, 0 minterms, how can we write a and b? A bar dot b bar, right? So for 1 and 0, so a is 1, so a is a, and b is 0, so b bar, right? So this is what we have. Now since we are talking about minterms, it has to be sum of products, right? So sum of products in the sense it has to be a bar dot b bar, right? So plus a dot b bar. So if you solve this, what you have using distributive law, a bar dot a plus a bar b bar plus a b bar plus b bar b bar, right? So according to idempotency law, a dot a bar, right, becomes 0, and we have this term and a b bar. So what about b b bar? We can take 1 b bar, right? 1 dot 1 is 1, right? 0 dot 0 is 0. So this thing is repeating, so we can come to a conclusion that we can take b bar. Now if you see this term a bar b bar plus a b bar, you can take b bar commonly outside, right? So it becomes a bar plus a plus b bar, right? So what is a bar plus a? It is actually 1. So b bar plus b bar, which is equal to b bar, right? So what we have identified that f of a b, which is equal to minterm 0, 2 is actually b bar. Now we have to find if this term here and this term here are actually b bar, right? So that is what we are going to find. Okay, now we can write f of so we can write f of a dot b, which is equal to max terms, right, 1, 3, right? We have a 1 and we have a 3. So how can you write 1? 0, 1. How can we write 3? 1, 1. Now see, this term is a max term, so if a is 0, a is a, plus b is 1, so it is b bar, right? This is min term, this is the max term, right? So here a is 1, so a bar, plus b is 1, so b bar. If you're talking about max terms, right, it has to be product of sums, POS, right? This is POS and this is SOP, sum of products, right? So which is equal to a plus b bar dot a bar plus b bar. Right now you can use distributive law, right? So can apply this a bar plus b bar plus b bar b bar, right? Same thing, right? So you can see both the steps are same, right? So now this thing becomes 0, and if you take b bar commonly outside, and once again the same can be followed plus b bar. Okay, so the answer is going to be right? You can cross check with this previous one. The answer is going to be b bar, right? So what we have here, this f of ab, right? This f of ab max term 1 comma 3 is actually b bar, right? Now we have to find the complement of the function f of ab, right? Min term 1 comma 3, if it is actually b bar. Let's see. Okay, now we have to find if this term here, I'll just highlight here, this term is actually b bar. So in order to find this term, we have to find f of a comma b first and complement it, right? So here you can see f dash of ab is being asked in the question, right? But we have to find f of ab and complement it. Now the question is sigma 1 comma 3, what happens, right? So we have a 1, we have a 3, which is equal to 0 1, right? And 3 can be denoted as 1 1. Now since we are dealing with min terms, if a is 0, right, a b are the variables, right? So a is 0, a can be a bar dot b can be b, right? Similarly, a is 1 dot b is 1, so ab. Now we can do this a bar dot b plus ab, right? Now what happens if you apply distributive law? A bar a, right, plus a bar b plus a b, right, plus bb. All right, now if you see this, it has to be 0, right? Now you can see, you can take b commonly outside from this term and this term. So a plus a bar plus a plus bb becomes b. Okay, now what about a bar plus a? It has to be 1. So this thing gets simplified to b plus b, which is equal to b, right? So this is actually f of ab, right? We need f dash of ab. So f dash of ab, which is equal to b bar, right? Similarly, if you solve for this, right, f of ab or f dash of ab, right, max term 0 comma 2, it will be coming to b bar, right? Try to solve this last parts, right, and put your answers in the comment section or put your doubts in the comment section.